On October 30th, 2016, astronaut Takuya Onishi returned from the International Space Station, or ISS. During his long-duration mission, lasting 115 days, he used experimental hardware that was previously installed at the ISS by fellow astronaut Kimiya Yui to carry out several experiments while coordinating closely with the ground crews. The mission theme of astronaut Onishi's stay was strength and trust. This is something only Japan can achieve. One of his tasks was the mouse epigenetics mission. In a first-of-its-kind experiment, working with the ground crews, small animals were raised simultaneously in environments with and without gravity, and then compared using the same equipment on Earth. The mice were also the first to spend extended time in space and all returned safely to Earth. The experiment yielded data on bone loss and muscular atrophy that is valuable for research on aging. This will help to realize a society of health and longevity. The airlock serves as a door between the ISS and space. One of the unique functions of the Japan Experiment Module is easily carrying microsatellites and experimental instruments outside the ISS. Astronaut Onishi worked on this airlock to be controlled remotely from Earth. The airlock is being used more often for extravehicular activities, such as releasing microsatellites and conducting material exposure experiments. The ground crew's new ability to control the airlock in place of astronauts gives the ISS crew more scheduling freedom and will add more opportunities for extravehicular use. In the future, even more experiments are likely to take place in space. Astronaut Onishi conducted an initial check of the electrostatic levitation furnace. It is the only equipment able to melt materials at 3,000 degrees Celsius in zero gravity and gather data on their physical properties. He also installed and ran an initial check on Japan's first group combustion experiment module for investigating the principles of efficient fuel combustion. This equipment can observe over 150 drops of fuel as they combust. Highly accurate data can be gathered because there are no natural currents in space. This will help improve fuel efficiency and develop cleaner engines. Astronaut Onishi ran experiments to grow high-quality protein crystals, one of the fields where Japan excels. Since proteins in zero gravity are left undisturbed by heat convection or precipitation, it is advantageous for growing beautiful, large crystals here. These protein experiment samples return to Earth with astronaut Onishi in a Soyuz spacecraft. The crystals will undergo further analysis. The valuable data will provide insights into protein structures that will aid in research for developing new drugs. In the Asian Tri-Zero-G program, astronaut Onishi conducted physics experiments proposed by young students from the Asia Pacific. For the first time, the students who proposed these experiments visited the Tsukuba Space Center to watch astronaut Onishi carry them out in real time. This project was covered extensively by the Japanese and foreign media. These Asian Tri-Zero-G experiments help people from the Asia Pacific gain a better understanding of human space activities. As the only Asian country participating in the ISS program, Japan has opened the door to extended usage of Kibo by Asian countries. On October 23rd, just prior to astronaut Onishi's return, he became the first Japanese to capture an American Cygnus cargo spacecraft in cooperation with the Tsukuba Space Center's flight control team. The Cygnus spacecraft carries the Japanese-developed Proximity Communication System, or PROX, which was developed for the H2 transfer vehicle Konotori. This achievement clearly showed the vital role that Japan plays in operating the ISS.
いろんな国際間のパートナーが共同で一つの目標に向かって達成していくという非常に典型的な例として今回のミッションが挙げられるんじゃないかなと思います。
Astronaut Onishi posted updates on social media almost every day during the 4 months of his long-duration mission. While introducing his work on space experiments and maintenance in an easy-to-understand way, he made it clear that space experiments were his most important mission on the ISS. He also frequently used social media to share breathtaking photos of Earth taken from the ISS and videos of life aboard the ISS. Responding to the many people who are interested in space, Astronaut Onishi often joined communication events with the public on Earth. Strength and trust. This is something only Japan can achieve. Astronaut Takuya Onishi achieved the goals of his long-duration stay on the ISS, in close cooperation with the ground crews to carry out several important missions. The responsibility of playing a core role in the ISS project and pioneering the future of space development using reliable technology will now be entrusted to Japan's third new-generation astronaut, Norishige Kanai.